Hello everyone and welcome to this video. Pandas is a powerful Python library that makes data manipulation and analysis a breeze. In this tutorial, we'll explore key Pandas methods using a company employee dataset. This will be particularly useful for HR and IT departments looking to analyze employee data efficiently. We'll cover everything from loading and exploring data to cleaning, transforming, and analyzing it. By the end of this tutorial, you will be equipped to handle real-world datasets with Pandas. Let's dive into a scenario where you work in the HR department of a company. You've been handed an employee dataset, and your task is to analyze it to gain insights into salaries, departments, and performance scores. Let's start by loading the dataset and exploring its structure. Alright, let's break this down. First, we import the Pandas library using the alias PD. This is a common convention in the Python community. Next, we use the read_csv method from Pandas to load our dataset from a file named dataset.csv. This method reads the file and stores the data in a data frame, which is a two-dimensional size mutable and potentially heterogeneous tabular data structure. Finally, we call the head method on our data frame. This method displays the first few rows of the dataset, giving us a quick overview of its structure and contents. The head method is a handy tool that displays the first few rows of the dataset. This gives us a quick overview of the data structure, helping us understand what we're working with right from the start. To understand our dataset better, Pandas offers some useful methods. The info method gives us an overview of the data types and any missing values. Meanwhile, the describe method provides statistical summaries such as mean, minimum, and maximum values for numerical columns. Here's what's happening in this code snippet. We call the info method on our data frame, which provides a concise summary of the data frame, including the number of non-null entries and data types for each column. This is crucial for identifying any missing data. Next, we use the describe method, which generates descriptive statistics that summarize the central tendency, dispersion, and shape of a dataset's distribution, excluding NA and values. This is particularly useful for getting a quick statistical overview of our numerical data. The info method reveals column names, data types, and any missing values, which is essential for data cleaning. On the other hand, the describe method offers statistical insights, such as mean, minimum, and maximum values for numerical columns, helping us understand the data's distribution. Next, let's identify the top performing employees. We want to find those with the highest performance score, which is crucial for HR to recognize and reward top talent. So what we are doing here is creating a new data frame called top performers. We filter our original data frame to include only those rows where the performance score is equal to the maximum performance score in the dataset. This is achieved using the max method, which returns the highest value in the performance score column. Finally, we display the top performers data frame, which lists all employees with the highest performance score. This code outputs a table of employees who have the highest performance score. It's a valuable tool for HR to identify and acknowledge top performers within the company. Now, let's look at salary distribution across different departments. Understanding this distribution helps identify any discrepancies and ensures fair pay across the organization. Here's what's happening in this code snippet. We use the group by method on our data frame, specifying department as the key. This groups the data by department. Then we select the salary column and apply the mean method to calculate the average salary for each department. This gives us a clear picture of how salaries are distributed across different departments. This calculation gives us the average salary for each department. It's a crucial step in assessing fairness and making informed budgeting decisions. Next, let's filter employees based on their experience. Suppose we want to identify those who have been with the company for more than 5 years. We can calculate their tenure using the joining date. All right, let's break this down. First, we import the datetime module, which provides classes for manipulating dates and times. We then convert the joining date column to a datetime object using pandas dot to underscore datetime. This ensures that the dates are in a format that we can perform calculations on. Next, we calculate the tenure by subtracting the joining date from the current date, which we get using datetime.now. We convert this difference from days to years by dividing by 365. Finally, we filter our data frame to include only those employees with a tenure greater than 5 years, storing the result in experienced employees. This gives us a list of employees who have been with the company for more than 5 years. This code extracts employees who have worked for over 5 years. It's particularly useful for experience-based analysis, helping identify long-term employees who may be eligible for promotions or other recognitions. Now, let's analyze department-wise performance. We want to check the average performance score for each department to understand which teams are excelling. Here's what's happening in this code snippet. We use the group by method on our data frame, specifying department as the key. This groups the data by department. Then we select the performance score column and apply the mean method to calculate the average performance score for each department. This helps us identify which departments are performing well and which might need improvement. This calculation gives us the average performance score for each department. It highlights high-performing teams and helps identify areas that may need additional support or resources. Finally, let's identify high earners within the company. We want to find employees earning more than $60,000. So what we are doing here is creating a new data frame called high earners. We filter our original data frame to include only those rows where the salary is greater than $60,000. This code outputs a table of employees earning above $60,000. It's a valuable tool for salary benchmarking and helps ensure competitive compensation within the company. Thank you so much for watching this video. Don't forget to subscribe my channel and see you next time.